Hello everyone and welcome to the third episode of the Python for Microscopy course. In this video, it's all about variables and data types. What are variables? In Python, a variable is a named storage location that holds data. Variables are used to store and manage information. You can think about variables as containers for data. So on the left-hand side, you can see a container, like a bucket, and on the right-hand side, the data you can put into the variable. If we think about it in a more accurate way, we can visualize the random access memory of the computer. On the left-hand side, we have the name of the variable, for example, age or surname. And this name is like a reference or serves as a reference to a certain storage location. And in this storage location, you will find a value, for example, age 19 and surname Smith. And these two values also have a type that this I will cover in a couple of minutes. So the variable is actually referencing to a certain location in the storage where you can find the value. How are variables declared? So to assign a value to a variable, use the equal sign as shown here. For example, age is equal to 25, name John, height 175, and is student true. Throughout a program, it's important to notice that you can update the value of a variable or use it in various operations. So for example, for age, if it changes from 25 to 26, you can simply say one line underneath age is equal to 26. And you can do that multiple times. And also, and this I will cover in a minute, you are not, it's not mandatory to use the same type of data for the same variable, but very useful for managing data anyway. So what are the rules for naming variables? Variable names can consist of letters, either underscore or upperscore, numbers, lowercase and uppercase, numbers, and underscores. And they cannot start with a number. They are case sensitive, so a variable named age with a small a is different than the variable age with a big A. And you should avoid using reserved words, for example, like, if, else, and etc. This we will cover in a future videos. The name is chosen by the programmer, and it should be meaningful and reflect the purpose or the content of the data it stores. Going back to this slide, so a variable called age should not contain information about the height. It should always contain information about the age, and so on. For example, name and then is student. It should always be reasonable, appropriate, meaningful. So far so good. Then let's move on to the data types. Data types in Python programming are a classification or a category that specify which type of value a variable can hold. It defines the characteristics of the data, such as the operations that can be performed on it and the storage method. So what does that mean? For example, a data type where only numbers are used, only a certain type of numbers, is different than a data type where there's only true or false. So this defines the methods you can perform on this data, and also for example, the size of the reserved memory, but this you will see soon here in the video. And Python is a dynamically typed language, so while the program is running, the type of variable is interpreted, or the data type of variable. So, and this is what I meant before, so you can assign a value to a variable, but then again change the value within running time. So this is a dynamic interpretation of the data type. It's not static. For example, in Java you have to declare the data type in the beginning Here in Python it's not the case, not necessary. Let's dive into the data types. For example, integer data types. For example, the age, 25. This is a numeric data type for whole numbers. But not all numbers can be represented as the storage is limited. So this you have to keep in mind. Now an exercise for you. How many numbers can be represented? If 8 bits, so 1 bit is a like an information in the storage that can store either 0 or 1. Not an information, but like a position in the storage, and it can store either 0 or 1. And how many numbers can be represented if 8 bits are reserved in the memory? If each of these 8 bits can represent 2 values. Next data type is float. For example, 1.75 for the height. It's also a numeric data type for numbers, but with a decimal point. And also here, keep in mind, it has limitations. So the number 1.333 and so on, so endless number of threes, cannot be represented exactly because this is an endless number of threes here. And next, the strings. So a string is a sequential data type. You can see here that you have these marks, these top marks, and these mark that a string is following after this equal sign here. For example, John. And it's a sequence of characters. A character, for example, J, O, H, and N. And this data type is a very special data type because the values you create after assigning or during assigning the value to the variable is immutable, meaning that the value cannot be changed after creation. But the variable assignment can certainly change after the first initial assignment. But we will cover all of these data types in future videos, so don't worry, this is just an introduction. The next data type is the Boolean type that represents truth values, so true or false. For example, is student is equal to true, and after finishing the studies, it is false. Next data type, the list. For example, a list of fruits, apple, banana, and orange is also a sequential data type. An ordered list, so the order of the elements matters, but a mutable list of elements, so you can delete elements, for example, apple, so you have a list of 2 elements, or add other elements and change the order. And it can contain, for example, variables or values of certain data types, but this is also a topic for future videos. So next data type is tuple. What is a tuple? It is also a sequential data type. It is ordered, so also the order matters. It is an immutable collection, again, as the strings. Like the strings, once a tuple is created, it cannot be mutated or mutated, but of course deleted by, for example, if there is no reference to this tuple anymore, then basically it doesn't exist anymore. So you have to create it again. So, and it can, for example, contain numbers or strings or integers, which is a number, or whatever data type. Also lists and also tuples. So this can also be like contain the same data type. Again, it's also true for lists and other certain data types. And yes, next data type is the dictionary. This is a very interesting data type. So you have a collection of key value pairs, and the keys map to the values. So for example, the name of like right here maps to the actual name, in this case John. The age, which is the key here, maps to a value of 25, and the Boolean variable is student maps to the variable true. This has a certain syntax. So it begins with this symbol here ends with it 2, and then you have this key value pairs separated by commas, and this double, how is it called in English, double points, as a separation between keys and values. But this we will also cover in a video about the data structures in Python or in general in programming. And the final data type I want to present to you is the set. In mathematics, a set is a collection of unordered elements and unique elements. So none of these elements can appear twice, or at least internally it's not represented, or there is no element that appears twice, and the order doesn't matter, so it doesn't matter if there's apple in the first position or in the last position, the set is the same. Finally, an information about a none type. So if there is an absence of value, so there is no value, or a null value, it's called a none value. Maybe you have programmed in Java, then you call it null. So there is no reference to anything, so just a none value, none type is not a value. What should you remember? Some data types are immutable, meaning their values cannot be changed after creation, for example tuples and strings. Others are mutable and can be modified, for example lists and dictionaries. But keep in mind, variables can be reassigned with new values, which are then stored in the random access memory. And each data type comes with its set of operations and methods that can be applied to manipulate and work with the data. This is the topic of the next video. For example, true plus false doesn't make much sense. 1 plus 4 does. But for example, 1 plus true doesn't make sense again. Finally, what I always, when I try to visualize it to myself is you can think about variables and data types as information stored in the random access memory. And depending on the data type, there's a specific shape or size of these information blocks. For example, for 23, or for the Boolean type, you don't need much space, but for complex data types, for example, for strings, which is a sequence of characters, Peter Smith, for example, you need more space. And this is very fundamental for us in the future, where we deal with much more complex data types named classes. Maybe you have heard of it, but this is a topic for a future video. Finally, you can find exercises in the GitHub repository. If you click on the link, you can also find it in the description and also in the channel description. You will find multiple files for exercises. You can open them. Let me show you. So we are now looking at the GitHub repository, and here you will find a short description of the project, a link to the YouTube channel, and right here a couple of exercises. So right now there's just 2. Let's click on the exercise for variables and data types. And it doesn't have this .py format, that's because it's a Jupyter notebook file. Let's click on it. And then you will see these blocks of comments right now, or blocks of code, describing a couple of exercises for you. And you can, if you use Google Drive or Google Colab, click on this button here and find a couple of exercises. For example, the first one, create variables for your age, height, and name. Then assign values to them with a correct data type, and finally print them out. Then you can execute them here with the play button. And this here is nothing important. You can run it anyway, then find the answer, and then try to solve all of these exercises, which will be or serve as a nice recap for the variables and data types. So finally, if you have any questions, feel free to leave a comment below. Also like and subscribe or share the video if it was helpful, and see you in the next episode.